What if I told you that a single experiment with two slits in a piece of paper completely destroyed everything scientists thought they knew about light and reality itself? Picture this. It's the early 1800s, and scientists are absolutely convinced they have light figured out. Isaac Newton had declared light was made of tiny particles, like invisible bullets shooting through space. This made perfect sense. Light travels in straight lines, casts sharp shadows, and bounces off mirrors just like you'd expect particles to behave. Case closed, right, wrong, dead wrong. Because what happened next would shatter this comfortable understanding and open the door to some of the most mind-bending discoveries in human history. The story begins with a brilliant young scientist who decided to do something incredibly simple yet revolutionary. He took a coherent light source and aimed it at a barrier with two parallel slits cut into it. Behind this barrier, he placed a screen to see what pattern the light would make. Now, if light really was made of particles like everyone believed, you'd expect to see exactly what common sense tells you: two bright stripes on the screen, one behind each slit, just like if you threw marbles through two openings in a fence. But that's not what happened. Instead, something absolutely bizarre appeared on that screen. Instead of two simple stripes, there were multiple bands of light and darkness, an interference pattern. These alternating bright and dark fringes could only mean one thing: light was behaving like a wave. When waves meet, they can either add together to create brighter spots or cancel each other out to create dark spots. This is exactly what was happening with the light passing through the two slits. The light waves from each slit were meeting and interfering with each other, creating this stunning pattern that should have been impossible if light was just particles. But here's where it gets even stranger. When they covered one slit, the interference pattern disappeared, and you got exactly what you'd expect: one bright stripe. Open both slits again, and the mysterious pattern returned. It was as if the light somehow knew both slits were open, and was taking advantage of this fact to create something entirely new. This discovery sent shockwaves through the scientific community. Everything they thought they knew about the fundamental nature of light had to be reconsidered. Light wasn't just particles, it was waves. Or was it? Because here's the thing that made this discovery even more revolutionary. Light still exhibited particle-like behavior in other experiments. This led to one of the most important concepts in modern physics: wave-particle duality. Light isn't just a wave or just a particle. It's both, depending on how you observe it. This sounds impossible to our everyday experience, but nature doesn't care about our intuition. The implications of this discovery were staggering. First, it completely revolutionized our understanding of electromagnetic radiation. Scientists realized that light was just one small part of a vast electromagnetic spectrum that included radio waves, microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays. All of these were the same fundamental phenomenon: electromagnetic waves, just with different wavelengths and frequencies. This understanding led directly to the development of countless technologies we use today. Radio and television broadcasting, Wi-Fi, cellular communications, microwave ovens, medical imaging, and satellite communications all rely on our understanding of electromagnetic waves that started with this simple two-slit experiment. But the wave nature of light revealed something even more profound about the universe. It showed us that reality at the quantum level operates according to completely different rules than what we experience in our macroscopic world. This discovery was one of the stepping stones that led to the development of quantum mechanics, arguably the most successful and mysterious theory in the history of science. In the quantum world, particles can exist in multiple states simultaneously, can be entangled across vast distances, and can tunnel through barriers that should be impossible to cross. The wave-like behavior of light was our first glimpse into this strange quantum realm. The technological revolution that followed is almost impossible to overstate. Lasers, which are based on the precise manipulation of light waves, have transformed everything from surgery to manufacturing to entertainment. The DVD player in your home, the barcode scanner at the grocery store, and the fiber optic cables carrying internet data around the world all depend on our understanding of light as an electromagnetic wave. In medicine, the wave nature of light enabled the development of advanced imaging techniques. MRI machines use radio waves, X-ray machines obviously use X-rays, and new techniques like optical coherence tomography use the interference properties of light to create detailed images of tissue structures. Even more exciting are the quantum technologies emerging today. Quantum computers, which could revolutionize computing by performing certain calculations exponentially faster than conventional computers, are built on the same quantum principles first revealed by the wave nature of light. Quantum cryptography promises unbreakable, secure communications by using the quantum properties of light particles called photons. Perhaps most remarkably, our understanding of light waves led to Einstein's theory of relativity. When scientists realized that light was an electromagnetic wave, they discovered it always travels at the same speed in a vacuum, regardless of the motion of the source or observer. This seemingly simple fact about light led Einstein to conclude that space and time are not separate, absolute entities, but are woven together into a flexible fabric called spacetime. This revolutionized our understanding of gravity, led to the prediction of black holes, and explained how GPS satellites can provide accurate positioning. Today, scientists are pushing the boundaries even further. They're creating artificial materials called metamaterials that can bend light in impossible ways, potentially leading to invisibility cloaks. They're using quantum entanglement between photons to create quantum networks that could form the backbone of a future quantum internet. They're even using light to trap and manipulate individual atoms, opening new possibilities in quantum computing and precision measurement. The discovery of light's wave nature also revealed something profound about the process of scientific discovery itself. Sometimes the most revolutionary insights come not from complex theories or expensive equipment, but from simple, elegant experiments that reveal the hidden workings of nature. Two-slit experiment, which can be performed with basic equipment, opened the door to understanding some of the deepest mysteries of the universe. Looking back, it's incredible to think that this one discovery, that light behaves as a wave set in motion, a chain of scientific and technological revolutions that continue today. From the smartphone in your pocket to the satellites orbiting overhead, from the laser surgery that saves lives to the quantum computers being built in laboratories around the world, it all traces back to that moment when scientists first saw an interference pattern where they expected to see two simple stripes of light. What aspect of light's wave nature surprised you the most? Drop a comment and let me know which of these discoveries blew your mind. I love hearing your thoughts on these incredible scientific breakthroughs.